So this particular paper on physics from JEE Mains was actually very mechanics heavy. The number of problems from mechanics were much more as compared to the other topics, but the problems were from simple to moderately difficult levels. So I start off with this particular problem, which was in fact very, very simple. So there is a meter scale of mass m, which is hanging from the ceiling by two ropes, A and B. It's given that the ropes are massless, and there is also an external load of mass 3m, which is hanging onto the meter scale at a position which is 0.75 centimeter from the left. So you have been given that the tension on this rope A is equal to kmg, and you have to find out what is this k. Actually a very simple problem. Let's straight away draw the free body diagram of this scale. Okay, so first of all, remember this is a meter scale. A meter scale means it is 1 meter in length. So first thing that should come into your mind is, what is the reference frame that we are taking? We are taking a reference frame which is at rest and looking into the scale. Okay, now the weight of the scale would be from its center. Okay, let's call this distance as L by 2. Of course, L is 1 meter, but for generalization's sake, let's write this as L by 2, and the weight downwards would be equal to mg. What else? The hanging weight would give a force downwards because of its weight, which would be equal to thrice mg, and that would be at a distance of L by 4 from the right or 3L by 4 from the left, whichever way you take it. What else? There would be two tensions, supportive tensions upwards. Let this be TA and let this be TB. You have to basically find out TA, and then from there you find out what is the K over here. For that, take the moments about this point, about this edge that I have darkened. So TB would not have any moment about this. Of course, mg, the small mg, would try to rotate the rod in this direction, 3mg in the similar direction, and TA in the opposite direction. So TA is the balancing force or the balancing moment provider over here. So if I take the clockwise direction as positive, then the moment given by TA would be equal to TA multiplied by L. L is of course 1, let's write it as L. Now the moment by mg, the small mg, would be equal to minus mg into L by 2, because it is acting at a distance of L by 2, and the moment given by thrice mg would be equal to minus thrice mg into L by 4, and that must be equal to 0 for the meter scale to remain in balance. Solve this out. What I get is TA is equal to mg by 2 plus thrice mg by 4. This is equal to 5 mg by 4. Simple calculation. And what do you see? You see that K is equal to 5 by 4. This is actually a very simple problem which is done. We will get into the next mechanics problem in the next video.